Simplify the radical expression. Assume all variables represent non-negative real numbers. So for this one, the first thing we want to do is we want to simplify anything we can inside the radicals. So on this first one, I can see I have m to the 9th, and it's a 4th root. Okay, so if you remember how we do this is we do 9 divided by 4. Let me just show you the reason. Oops, that is a 4. So if I wrote out 4, 5, 6, 7, 8, 9. So for every 4 m's that we have, we can take 1 m out. So there's 1 m that can be taken out with those 4. There's another m that can be taken out with those 4. And then I would be left with 1 m on the inside. Okay, so this is why we just can divide, because we're just saying, okay, how many 4's are in 9? How many times does 4 go into 9? Well, it goes in 2 times, so we still have the 4 out front. Then we have m squared. Similarly, we divide, in fact, let me put this here so we don't forget. Keep our m on the inside. We have 6 divided by 4. Well, 4 goes in once, and so then we'll have 2 left over, so p squared, and then minus 2m squared p, and then the 4th root of mp squared. Now, for terms to be like terms, there are a few qualifications they need to meet. So first, they need to have the same index, which they do here. Second, they need to have the same numbers or variables under the square root. Well, they do here. They both have mp squared. They also, if there are variables multiplied in front, those have to be exactly the same. Well, notice we have m squared p and m squared p. So these would be considered like terms, okay, because they meet all of those qualifications. So we have 4 m squared p 4th root mp squareds. We're going to minus 2 m squared p 4th root of mp squareds. So left over we have 2 of these gigantic m squared p 4th root of mp squareds left. And that is our final answer. Nothing else can be simplified. We can't break it down any further. And so that would be it.